You need help with area and volume problems on the SAT. Well, I've got 3 keys to help you answer any area and volume problem on the SAT. But first, I've got a question, I've got a timer, let's solve it. Okay, a cylindrical can containing pieces of fruit is filled to the top with syrup before being sealed. The base of the can has an area of 75 centimeters squared and the height of the can is 10 centimeters. If 110 centimeters cubed of syrup is needed to fill the can to the top, which of the following is closest to the total volume of the pieces of fruit in the can? So the question is asking us, what is the total volume of fruit in the can? And we know that the can has syrup and fruit. And we're given the area of the base and we're given the height, which means we can find out the volume of the cylindrical can. So first, let's draw a picture, very rough picture. And we know that the height is 10 centimeters, and we know that this area is 75 centimeters squared. Now, to figure out what the volume is, I would take the area of this circle and multiply it by the height because basically we just have a bunch of circles going all the way down. So 75 centimeters squared times 10 centimeters equals 750 centimeters cubed is the volume of this entire can. So now the question's asking that we would need to fill the can with 110 centimeters cubed of syrup to fill the can to the top. So that means that right now this is fruit and this would be syrup to get to the top. So this would be 110 centimeters cubed. What is this? Well, we know that x plus 110 centimeters cubed equals 750 centimeters cubed. Subtract 110 from both sides, and we have x equals 640. C is our answer. So the first key is know your area and volume equations. So as you can see here, we have this broken out by area and by volume. And really what you're going to need to know for the SAT is know how to calculate the area of a rectangle, a triangle, and a circle. That's pretty much all you're going to need to know. And so what that means is that you are really doing yourself a huge favor by remembering how to calculate the area of those 3 things. So first off, square, rectangle, you're just going to do length times height, length times width, whatever. One side multiplied by the other side gives you the area of a square or a rectangle. Now for a triangle, we get a little different. We take the base multiplied by the height and we divide by 2. So let's take a look at this example that we have pictured below and put some numbers to it. So we have this example here, 1/2 base times height. That means if I have a triangle like this and my base is 3 and my height is 2, what I'm going to do to find the area, I would do 3 times 2 divided by 2 equals 6 over 2 equals 3. That is my area. I have my base, 2 equals my height. I multiply them together and divide by 2. Now with a circle, where it's always going to be pi r squared. So we know that the radius will always look something like this. If you see a line going all the way across like this, that is your diameter. And we know that the radius is just 1/2 of the diameter, or the diameter equals 2r. Okay, so if you're ever asked what the area of the circle is and you're given the diameter, so just divide the diameter by 2 and then square the radius and then multiply it by pi and you'll have the area of that circle. So if we look at this example here and we make r equal 12, so the area would be equal to pi 12 squared equals 144 pi. That would be the area of the circle. Key number 2, know the difference between units, units squared, and units cubed. So like we saw in the first example, 10 was just the height, one-dimensional. And then we had centimeters squared or units squared. You can replace centimeters with inches, millimeters, whatever you want. The point what I'm trying to make here is that I'm multiplying some type of unit by another type of unit, and that gives me the area. So area will always be some type of unit squared. And then volume will be units cubed. So a centimeter times a centimeter times a centimeter gives me centimeters cubed. Just something you want to be aware of when you're going through the problem, and make sure that when something says what is the area or something is centimeters squared, you know in your mind to tell yourself and say, okay, centimeters squared, that should be the area, or units cubed, that should be the volume. And digging a little bit more into volume, like we talked about, volume is length times width times height if we're looking at this cube here. And it's like we talked about again, it's centimeters cubed, yards cubed, meters cubed. Look at your reference sheet if you don't know how to calculate the volume of something, the volume of a sphere. I can't remember it off the top of my head right now. Use what you have at your disposal so you don't make silly mistakes. Key number 3, make sure you draw a picture and break down the problem into smaller problems you can handle. Too often I see people not drawing enough pictures when it comes to area and volume questions. Like I did in that first problem, I drew a can and I showed how fruit made up one portion of it and then syrup made up the other. And I was able to clearly see that there were 2 things in this can, and I was given the amount of one thing, which was syrup, and I was given the volume of the total can, so all I had to do was subtract the syrup volume from the total volume to find out what my fruit volume was. Simple? Yeah, I thought so. Question number 2. A granite block in the shape of a right rectangular prism has dimensions 30 centimeters by 40 centimeters by 50 centimeters. The block has a density of 2.8 grams per cubic centimeter. What is the mass of the block in grams? Density is the mass per unit volume. So let's start with density. Density equals mass per unit of volume. Okay? And we're given that density equals 2.8 in the equation above. And then we're given that some block looks like something like this. I suck at drawing, just plain and simple. So we know that it's 30 by 40 by 50, and so we need to find the volume, because we know that if we find the volume of this, we can plug that into this equation up here because we're asked to find the mass. So if I know that mass over volume equals 2.8, then I know that mass is going to equal 2.8 times the volume. So I need to find the mass. So I know I have my block here. I have everything I needed to multiply the length times width times height. And so I'm going to do just that. I have 30 times 40 times 50. That's going to give me 60,000 as my volume. So 2.8 times 60,000. And without even doing any more math, I know it can't be A, it can't be B, it can't be C, because my volume alone is 60,000 and I'm multiplying that by something greater than 1. So I know right off the jump, it's going to be D. Question number 3. What is the volume in cubic centimeters of a right rectangular prism that has a length of 4 centimeters, a width of 9, and a height of 10? Now I know this sounds super easy if you know what volume is. And let me tell you, it is. This is one of the easier questions I've seen on the SAT if you know what volume is. So let's jump into it. So we're asked for volume of cubic centimeters. And we have a right rectangular prism that gives us everything we need to know. We know the volume of a rectangular prism looks something like this, equals length times width times height, and we're given that the length is 4, the width is 9, and the height is 10. When we multiply those together, we get 36. 36 times 10 is 360. And 360 is our answer. All right, that covers volume. I hope that was a ton of help for you. Do the homework you see here below and go ahead and watch the next video.